Alright guys, so I guess the setup should be ready by now, and therefore we can start the stream. My idea was that I missed a contest, AtCoder regular contest 118. So I wanted to upsolve it, and also I wanted to, I don't know, try to stream it, because in theory it should provide more engagement, like you can actually ask some questions live, which should be good, right? So of course there will be some delay, but I hope it still works fine and you can still, I believe the output quality of the video is a bit low, so it's like not HD for whatever reason. Yeah, thanks man. So apparently, hi everyone. Yeah, I will be sometimes. With some delay. Yeah. Hello guys. So like my setup is a bit complicated because yeah, I could not get both, like if I open everything on one laptop it will be just a bit overloaded, so I have two laptops and I will sometimes look to the side because yeah, the chat is open on the second laptop. So but yeah, the plan is to upsolve this contest and potentially answer some of your questions if you get any. It is regular contest, so not as easy as beginner contest, but still we should be good to solve, like I hope for first 4 problems, and then we'll see how it goes from here. Yeah, so I will try to look at the chat sometimes and answer questions if you get some. Okay, so we can start virtual participation straight away. We may actually change it to like, I don't know, 38 minutes, so right now. Yeah, it will start in a second now. I believe that first, like, I don't know, 2 problems should be easy. Let's go straight to task and also open a submit page. Go to all tasks. So problem A, tax included price. The consumption tax rate in the Republic of AtCoder regular contest is 2%, where T is a positive integer. There is a shop called Seisuya, integer shop there. It sells each positive integer A for a yen. Yeah, it's a Japanese currency, excluding tax. That is some complicated formula. Yen including tax. Okay, yeah, that makes sense. So we multiply by the 1 plus tax percent and then round down. Okay. So although that shop sells every positive integer, there are some positive integers values that cannot be tax included price of an integer. Among those values, find the n smallest value. Okay. So yeah, I think I got what they want from me. Font, you mean in Sublime Text? I don't really know, it should be either consoles or something. I think I can check preferences later, but I'm pretty sure that it's something like consoles. So it is like default monospace font on Mac, but you can also get it on Windows if you want to. Okay, so we will need some examples to work through this problem. Yeah, okay. Like the idea is that if we have an integer 1, it gets converted to that complicated formula, which is 100 plus t over 100 times 1. And the same goes for every integer. So something like this. But these values, they, like for small values of a, it's likely that when you apply the tax and then round down, nothing will change. Because, I don't know, you add 1% to 1, the price goes to 1.01, and then you round down and nothing changed. Yeah, so for some small values, nothing will change. Potentially, if t is like 1%, then, I don't know, something like 100 will get to 101, right? So we will skip the price of 100. And the problem asks us to find like nth values that we will skip. So for example, here it was like 99 would still get to 99.99, but then it will get rounded down, which still stays at 99. And 100 already goes to 101, so here we skipped 100. And we want to find the nth number that we will skip. Looks messy, a bit messy. Oof. I don't know, based on n, we clearly cannot just generate first n numbers, so there must be a smarter way to get it. What is it? What is it? One thing I always do when I don't know how to solve the problem is like read input, because I will need it either way. So t is a percent and n is our number. We can also always copy the test cases here. Okay, so some ideas that we can try like generate all numbers that can be the value of that expression, and potentially there are more of such values than there are absent values, but it doesn't look like it. The second thing is probably just go for some general formula, I don't know. Or maybe we can maintain a window of numbers that will be missing. Somehow. Yeah, okay, so for t equals 1, we skipped 100. What is the next number that we skip? Looks like 200 because if we take something like 199 multiplied by, like, add 1% tax to it. No, we won't actually skip 200, right? Because this is what? Plus 1.99, which is 299. So when we run this down, it will be actually 200, so we must have skipped some value before it, right? Maybe we'll skip 201, I don't know, let's see. We get 200 and then we get 2 more yens, which is indeed 202. Okay, so we somehow get this sequence of we skipped 100, we skipped 201. Okay, what is the general thing? We have 100 plus d over 100 times a. Let's think, what if we suppose we skip x, right? Which conditions should hold then? Like for some value of a, this should be smaller than x, and then for a plus 1, this should be greater or equal to x, right? So this is a necessary condition to skip the value of x. I really don't like it how we have floor function here. There must be some easy way around it to like get windows of numbers that we will skip. Or potentially we can get windows, and by windows I mean like clearly all numbers that we get, like first numbers that we can get, they start from 1 and go up to I don't know how much, but let's say from 1 to, you know, R1. And then we have another window, like all numbers in this window, there is a value of n that produces, for every value in that range, there is a value of a that results in that value from that range. Maybe we can generate one of such intervals based on the previous one. That looks like a really tough problem to start a contest with. Oof, I was not ready, I must say, for such problems. Rounded down. Do we need rounded down here? I don't think so. Like why? If we rounded down and the value became smaller than some value, some positive integer x, then it was already smaller, right? You cannot skip an integer due to this, so I believe that these inequalities result in something like this. Oh, of course, to skip actually the value of x, we should be greater or equal to x plus 1. Okay. Then we can multiply on both sides. Oh, actually, a has to stay here. There's only 100 that we multiply by. So this is at smaller than 100x, and if we add 100 plus t, it becomes more than, okay. So if we subtract 100 from both sides, it will result into something like this, which looks very reasonable because, like, yes, we added something and then we passed 100x, right? So the whole chain of inequalities looks like this, right? So here we have one multiple of 100 plus t. Here we have a multiple of 100, and here we have another multiple of 100 plus t. Maybe it has something to do with our problem. And we add t and we get over that value. Great. Okay. So we have to solve this for either x or a, I believe. Let's try to do both, and maybe some of this will work. But that's... no, okay, I definitely did not expect that level of problems from 300 points. Like, what? We might be missing something obvious about that problem. Do you know anything obvious that we are missing? Because I don't. Yeah, so if we solve for a, what should we do? We should subtract t from here, and then we should divide by 100 plus t. So a is at least that much. If we're solving for t here, then we have to divide by this straight away. Does it tell you anything? Because I really don't know. Maybe problem B is actually simpler and we should solve it first and then come back to that strange problem A. I don't really know. We must be missing something, and like sometimes if you're missing something, maybe you just need to solve some other problem and then come back with a fresh look. So unless you guys have any ideas, maybe we will just start with problem B then, because that's a bit strange. Do you? I'm just looking at the chat, but apparently nobody says anything, so... Yeah, I don't know, we've been solving this like for 15 minutes and got no ideas. Maybe we should just continue with the next problem. I know it's a bit disappointing start to the stream, but like, who could have predicted that, right? So yeah, I will close it for now. If you get any ideas, you can just write them in chat and we'll discuss. But it definitely looks like a strange problem A for me. Or maybe I just haven't solved AtCoder regular contest in a while, but I believe that the like 300 points problem should not be harder than ABC. 300 points problem, and usually after 15 minutes, after 10 minutes, we actually already solve ABC, problem C. Okay, maybe it's just a strange problem and we need to look at it from a different angle, which we don't know yet. Maybe there is some simple math formula that I cannot figure out. I don't really know. If you participated in RC, maybe it's obvious to you already because you know it, but I don't see what is the formula. No, I mean, on average, I know how many numbers we will skip, right? Because first, well, actually, wait. Wait. Yeah, I must be very stupid. Thanks to someone who wrote something in chat because, yeah, it persuaded me that there is some formula, so maybe we just need to think like very stupidly. Let me explain what I mean by that. So suppose we take all numbers from 1 to, I don't know, k, right? And then what is the image of that set? Obviously, all numbers will be different, because we add at least 1 to the price all the time because tax is non-negative. So yeah, let's say that f of a, well, f of t and a is that formula, right? So it is 100 plus derivatives plus t over 100 times a, right? Then f of t a plus 1 is strictly greater than f of t a. So all these numbers from 1 to k, they have different images. So f of t1, f of t2, etc., f of t and k, these are k different numbers, right? And apparently we can just take whatever is the largest number, which is clearly ftk, and then we subtract k, and this is how many numbers on the interval from ftk, from 1 to ftk, don't have a pre-image under that function. So, okay, and we are interested in the smallest k for which this value equals n, right? Well, like clearly we can binary search for k. Maybe we can simplify it to get like explicit formula. But I don't know. Well, let's just binary search. What is it? So value k equals 0 is clearly too small, right? Because n is at least 1, and if you substitute k equals 0, you will get just 0, I believe. Well, actually, we don't sell like 0, but because it's not a positive integer, so the value of low is like always smaller than you need strictly. The value of high, I believe, can initialize with something like this. It will be more than enough because tax percent is at least 1, which means that we skip at least one number in 100 of numbers, or approximately so. Maybe 1 in 101 numbers we definitely skip. So actually I believe that we only need like 10 to the 11th, but let's be a bit extra safe, I guess. And then goes our standard binary search, and the value of low, we agreed that it is always smaller than we need, so we will output the value of high. yeah, let's say auto function f, it will take integer. Oh, we should just make everything long. I don't really see a reason not to. We are not carried about memory usage here, I'm pretty sure. Or actually, this will be our decision function, right? So we take what? We take that expression. I believe we need to write it like this for C++ to interpret it correctly. And we subtract a, and we should return if it is at least n. Oh, let's be extra safe. If f of middle, it means that our value of a is at least the desired value. In this case, we should update high, otherwise it's not enough, and we should update low, I believe. Yeah, so should be something like this. Let's actually check if 13 f of middle. Oh, because I forgot to pass p apparently. Well, that's interesting. Apparently we always go to high. So we always, like, because we printed that huge value, it means that we always incremented low, I believe. Yeah, there should be one line formula, but like, it is very likely that we will make some mistakes if we try to derive it straight away. So maybe, or maybe this just overflows because a is too large. Okay, well, I guess we take, yeah, because I did not recompile apparently. Yeah, now we get the value of 10. So yeah, because we set high to high, sorry for that wording, this is an overflow because we need a to be at most like 100a should not exceed whatever is the maximum value for long. Well, that is not equal to what it should be equal to. Probably. I don't know. Like, I don't guarantee that these solutions are the simplest ones. These are just some solutions. So maybe there is a simpler version of that. We got that test case wrong for some reason. Why would that happen? This is the largest value, so this is how many values we skipped. And we find the smallest a that results into this. Okay, let's see just how wrong we are with the third test case. Okay, apparently we do something wrong. But this is a value that A gets mapped to, right? And then we saw, like, we need the smallest A for which this is true. For which we skipped at least n numbers. Are we sure that this is a correct expression? I just don't understand what may go wrong here. So this should be the price of an integer a after we apply the tax, right? And we say like, okay, we have a integers that get mapped between these two values, from 1 to that value. So the difference is how many we skipped. Okay, what if we just copy paste it here explicitly? Get rid of this. Oh, apparently this is not enough. Okay. No, I just checked the answer to the sort test case. Like we set high to low this time. But it did not really help. Okay, maybe we just need to do some debug printing. So we skipped that many values. I would like to see how many we skipped and what was our guess. Yeah, I know it's a bit slow start, but it's like... Oh, maybe we are fine. Okay, look. we are finding the value of middle, but the skipped value will be this minus 1, right? Yes, so that, like we were outputting 167 for that test case because 167 was getting mapped to 172. So what we actually want is this, I believe. Let's check if it works now. Okay, yes, okay. So the problem was that we were looking for a value of middle, right? So you see? Yeah, let me just get back to our function sync. So we said that 1, 2, etc. middle got to 1, no, got to f of 1, f of 2, etc. f of middle. Therefore, we skipped that many values, right? This is how many we skipped. Okay? But the real values that we want to output, like we want to find when this equals to n, and I was printing middle, whereas I actually should print f of middle minus 1, because it is the last value that we skipped. So if we recompile it now and rerun it, we should be good to go. So 10, 171, and whatever that number is. Yeah, let's try it now. Okay, it got accepted. Sorry for that very slow start. Yeah, I believe that there is some formula that you can observe from samples. I don't know, I just could not see it straight away, so I decided to go with a safer approach. Yeah, we just had to be careful to output the last skipped value and not the value of middle, which leads to n skipped numbers. There's a small difference between them, but there is some. Okay, so now that we got accepted, we can go to problem B. Okay. So okay, problem B, village of M people. The Republic of AtCoder regular contest has n citizens, all of whom play competitive programming. Much respect to all of n citizens. It's not easy to repeatedly participate in contests. Each citizen is given a done. Great, yeah, like if you noticed AtCoder, users actually have dans or queues. Like if you're a bit lower, then I believe you're not like first dan or whatever it's pronounced in Japanese, but like you start from, I don't know how much, probably from 30 queues, and you got, so, I don't know, 29 queue, at least in the case of AtCoder. And you get to 1 queue, then you get to 1 dan, and from here onwards it increases. I don't know what is the reason behind this system, but I believe that something like this is also the ranking system in Go, and apparently at AtCoder as well. Anyways, let's get back to our problem. A national census has revealed that there are exactly AI citizens with dan. I should just Google how it's pronounced, because some people who know how it is will hate me. No. Then. Okay, that is just very complicated, so I'll call it then from now on. To make this data easier to understand, the king has decided to describe the country as if it were a village of m people. Set the number of people with then I in the village, bi, so that max of what? Excuse. Okay, so we kind of group people together, I believe. Like, we say there is 1,000 players of Dan 1, 2,000 players of Dan 2, and then we substitute them with like values of 1 player with Dan 1 and 2 players of Dan 2. Looks something like this. So that maximum of I is minimized. That's strange. It sounds like... No, it legit sounds like we want to just divide them by greatest common divisor. Because if we don't, like if we set... If we change the, like, if we divide them by GCD, oh, okay, apparently we are given a value of m, okay. Oh, that's complicated. Why do we always have these kinds of expressions and we don't have just some beautiful problems? Okay. No, that's fine. So we want to compress them to a given overall size, and then we want to choose bi such that maximum of these differences is minimized. Actually, what is this difference? Like, it's bi over m minus ai over m. Right, if we multiply every such number by mn, then we all, like the maximum, the index I for which the maximum is obtained won't change. So we're actually interested in minimizing these values. So maximum over I of these values should get to minimum. I mean, we can do another binary search over that. No, it will be just some stupid contest if it expected us to do 2 binary searches in a row. But like in theory, we can check pretty efficiently if it is possible to make that maximum smaller than some value, with the idea that for every bi there will be a small range of possible options. And we want then to check if it's possible to obtain the sum of m, which is actually not... Okay, I believe it was not the expected solution, but we'll do it anyways. Just because... just because we can Yeah, the idea is that like to find the minimum value of any expression with a binary search, you can check whether it's possible to obtain values that is smaller than k. And how do you check if maximum over I is smaller than k? Well, you check that this condition holds for all I. What does it leave us with? Like this inequality, you can rewrite it, because it essentially says that this is not much smaller than this and not much bigger than this. This is at most like so, and at least like so. And then for each bi, you get that range, like after you divide by n. But here you have to take a C-link, I believe. And here you have to take the floor. It also must hold for all I. So for every bi, you get a range of possible values from Li to Ri, and then you want to check that M is in sum over L of left boundaries and sum over I right boundaries. Okay, I hope you will forgive me that over usage of binary search, but yeah, sometimes yeah, no, I believe that the expected solution for problem A was actually to derive the explicit formula, which I failed to do, and you guys didn't fail to do because you are smarter than me, of course. So maybe it's, yeah, just forgive me, and we'll get to more interesting and diverse problems soon, I believe, at C or B or something like that. So we should take I named it K, so we will go with K here. We'll return the Boolean value, of course, and allow like we should set the value of low to some values that can never be achieved, and I believe that, like it is possible that we will get the error of 0 if we again able to like divide by GCD or whatever. And then we should set the value of height to something, to some value of error that is always possible. Oh, and we will also have to print that set, which is not a big deal, I believe. We will solve that problem in the end. Okay. It's more important to check. Well, actually, K, I named it wrong. Let's say E for error. Like, can we get error that is at most E? Yeah, I want to separate these bounds, getting bounds, like Li and Ri into separate function, just because it contains some complicated expressioning. return a pair of values. So first value is AI times M. We captured M here, so it's fine. Then we subtract error and we divide by n, and we want to round up. What is the standard way to round up? Add that many and round down. That much actually, yeah. Now we want to take AI times M, add E, again divide by n, but this time we want to round down, so we don't have to do anything here. Okay, so we got our bounds. Oh, actually K is the size of the container. Probably everyone already noticed this, apart from me, although I don't see messages in chat screaming at me about this. Okay, so no, we can't do it like this. We will need to do some serious work here. I guess we'll just convert everything to long, because I don't know like where it will be needed. But somewhere for sure it will be necessary. So here we can take the bounds, of course it's Li and Ri, of AI and then the given error, right? This gets incremented by this gets incremented by this, and then we return that left is at most M and M is at most right. If it is, then we are good to go. What is the maximum error after we multiply it by Mn? What is it? I don't know, maybe Mn plus 1? Minus 1 plus 1? I don't really know, let's say like this. Okay, so here goes our boring, I believe, binary search. If it is possible to get at most such error, then we should update high, because high is always possible, low, remember, is never possible. So if it is not possible, then we can update low. Here, high is the answer that we can get. And what we need to do is we need to find some values between Li and Ri. Remember that we have Li is at most Bi, which is at most Ri. So we have to find such values of Bi, which are within given bounds, and give the given sum, which is within the sum of bounds. It should not be complicated. Just in case. Just in case, we will use variable I in some expression. Now we know what is the expected error. We should get this. And then do something with it. Maybe we should do it in like 2 loops. So first we actually get these values, which we could return from that function, but whatever. So now we know bounds for every such thing, and say difference, like we know that we want to get the sum of m. And if we take minimum possible value, then we will get the sum of L. So we want to take that much more than minimum possible value, okay? What it lets us do is the following. So we take this, then we say like difference for that element is what? At most Ri minus Li, and also at most difference. So difference will get decremented by that value, and Bi will get Li plus that difference. We actually have 4 input files for that, 4 sample test cases for this problem. Maybe because it requires some, or it has some issues with precision. I don't really know. Let's test it. So let's compile it and then test it. 3, 6, 11 actually looks good. 34, 34, 34 does not look good because we didn't get the correct sum. How would that happen? How could that happen? Maybe, wait. Okay, and I read everything in the correct order. Okay, so we had 3 people and we want to scale them up to 100. And somehow we got the wrong values. Oh, maybe it's not always okay, like bounds can be inconsistent, right? So what I imagine we need to add is if Ri is smaller than Li, then we can just return false, probably. No, this still did not solve our issues. Let's just check other values. So sample. Okay, so we only have problems in this sample output too. And I'm not exactly sure how do we have problems here. Okay, that's not a big deal. We can just, I don't know, print what is the value of a left bound for the current number and what is the value of the right bound for every value, for every element, I should say. Yeah, I definitely did not write AtCoder regular contests in a while. Okay, so for some reason, left boundaries are 33. And then I don't really understand how we ended up here. Let me think actually. So the bounds are correct. Like you want values from 33 to 34. But for some reason, like let's think, m is 100. Sum of left bounds is what? Is 99. So we say like we want to add 1. It says, okay, I will take 1. Like the difference here is 1 and here is 1. Here we should subtract. Oh, okay, yes. You see, I'm really not focused today because that was a simple. Like we had two inequalities which said like the difference for the current element is at most first value and at most second value. For some reason I decided to take max of them, whereas I should obviously take minimum, because like if I say one value is at most 10 and at most 15, then the union of these inequalities is that this value is at most 10. 10 is the minimum of 2. For some reason I decided to take maximum, and yeah, it was just stupid. I believe that now we are getting the correct answers, at least the expected ones. Yeah, I think so. So we can just get rid of this. Let's quickly test everything once again. Isn't binary search like the coolest thing to do? Well, it is often like interesting to implement if they check if they like this function, which determines whether the value is feasible or not. If it is interesting, it can be an interesting subproblem in itself. Like for some, I don't know. Have you seen a problem where you wanted to something like maximum flow, but you couldn't really employ any of max flow algorithms straight away, and you needed to do a binary search over like some supplementary value related to maximum flow. So this check function was to actually find maximum flow, and then you were checking like if this flow is possible, like the edges, the weights of edges, or the capacities, I should say, of edges were a function of some parameter, and you wanted to find the maximum value of this parameter for which there was a max flow of at least, I don't know, at least of some given value. It was an interesting binary search problem because like it was, the check function was a problem in itself. Let me just quickly check visually once again that all values look correct. I think they do, and we can just submit. I hope we don't have any stupid overflows. No, okay, we got accepted, wasted a little bit of time here, probably because that value of high is over. Yeah, we could just go with m, right? No, could we? No, after we multiply by mn, I don't know, let's leave it as it is. We got accepted, and that's all we wanted from that problem, to be honest with you. Okay, so problem C, Coprime Set. Things should get interesting around here, but no, it's still a 500 problem, so like ABCE. Problem E from AtCoder beginner contest, approximately of the same value. But actually, I must say that last time in ABC 200, problem E was pretty heavy on the implementation side, but let's see what they have for us this time around. So we're given a positive integer n. We want to print an integer sequence of n numbers satisfying all the following conditions. So all elements are not huge, all elements are distinct and coprime. Wait, no, every pair of elements is not coprime, but overall they are coprime. But overall they are coprime. Every value is very small, okay. Oh, and all, yeah, okay, all integers should be different. That's what got me thinking, because like my original idea was to take, I don't know, 2, 6, 6, 6, 6, a bunch of 6s, and then 3. Right, because clearly, oh, okay, 2 and 3 are not coprime. So probably we should have taken, I don't know, 6, a bunch of 6s actually, 10, 15, right? Every pair is clearly not coprime, but in general they are coprime because 15 is not divisible by 2, 10 is not divisible by 3, and 6 is not divisible by 5. And the problem is that we want all numbers different. Well, I believe that we can just say like, okay, now this is 6 times p1, 6 times p2, etc. 6 times, I don't know what, pn minus 2, and 10, 15. And it's p1, p2, etc. They are just prime numbers, like, I don't know, 7, 11, 1, 10 to the 9th, plus 7, although we probably should not have that huge numbers. All multipliers. Oh yeah, you're right, we don't have to multiply them by pairwise distinct primes. Yeah, we can just say like, okay, this is 6, this is 6 times 2, and this is, I don't know, 6 times n minus 2, n minus 3 probably. Or n minus 2. Yeah, that also works. Ah, okay, so you're saying like this is still too much because n can be up to 2500. Yeah, that's right. So maybe we also need to take like 10 times 2 and things like that, and then we are good. No? Let's think. We have 10,000 is maximum numbers that we can afford. If we divide it by 6, we get approximately that many numbers. When we divide it by 10, we get 1,000 numbers. And when we divide it by 15, I don't know how many we get, but it's irrelevant because we already have enough. Yeah, so it is like this, and then in total we have 3,000, I don't know, over 3,000 numbers, and we only needed 2,500. Inclusion exclusion principle. Oh, you're right, we actually have to subtract like, I don't know, 10,000 over 6 times 10, things like that. So I believe that the formula overall is like 1/6 plus 1/10 plus 1/15 minus 1/60 minus 1, what is this number, 90s, minus 1/150, and then plus 1/900, which should be enough. Then 3 kilometers. Okay, so yeah, it's 3,000. So we have a bit of a breathing space here, there, everywhere. Oh, you know what? I will just say like we construct a set. Oh, not now. I don't know. Well, we will construct just a set of these numbers. So for like, I don't know, I get 6, I is at most 10,000 plus I. No, not plus I, but I plus equals 6. Okay, let me just plug it here. So I want to have a special case for n equals 3. Because like with a set, I will take n smallest numbers, but this set actually starts with 6, 10, 12, which is not good for our purposes because they are not coprime overall. So if we take 10 here and 15 here, we can actually have them equal to how many? We want to take n numbers, so we can construct a vector from 2 set iterators. They will be actually sorted, although it was not necessary for our problem. And then we can just print. Nice problem, actually. I think it was very nice. We only have one sample case. No. We will have more. Yeah, you can see that we ended a bit early, so yeah, probably we have some of a gap, as you were saying. Yeah, that's true. For n equals 3 it works fine, for n equals 4 it works fine. I believe we can just submit this straight away. Very nice problem, actually. Well, some people may disagree because it's a constructive problem, and a lot of people don't like constructive problems, but hey, it's like very nice number theory. Also, inclusion, exclusion. Yeah, it got accepted, and this problem only had 14 test cases, which Sync is a bit strange, but whatever. I don't actually know where we will end. We started like what, 77 minutes ago, so we are very, very slow. Let me check how. Wait, we have 47 minutes remaining. Okay. I think we should be able to solve at least D. I don't know about E. Based on the time that we have left, maybe, well, it's Upsolving, so we can take a bit more time. But I will have to leave at approximately 8 p.m. So we only, like, if we were to follow the rules, then we have 47 minutes, and if we don't, then we have like 70 minutes. Just to give you a sense of how long this stream. Next function? That's a good question. There is std next. It takes in an iterator and increments it n times. But if iterator is random access, then it it's basically like if you have an array A, right? A is like an integer array of, I don't know, 100. Then I believe you know that you can say like, take me A and get me to the 17th element. This is just an address in memory. You can dereference that address and get a value out of here. So pointer arithmetics. So if iterator is random access, then this is basically equivalent to the following. So we take next of A begins 17. It works in constant time if A, well, it won't work like this, but it will work like this. Probably if it is a vector, then you don't need like to call next if you can just say like, give me a 17, right? And this will be still fine. But if it's a set, then you can't really access its element based on index. So you want to take like whatever is the 17th element of a set. And you can get an iterator to it with such a call of standard function from the standard library. And it will return you an iterator. Of course, iterators of std set are not random access. So for set, it will actually take all of 17 time. I mean, in general, it will take all of k operations. So probably you don't want to use it like very often. But if you only want to slice your set, right? So we have a set, and we want to slice it. So we basically take first n elements. So this is, I believe, a completely fine way to do it. So we take whoever, we can construct a vector from two iterators. It will say like, initialize iterator here, go until it's equal to this, and take all elements into our vector. So this basically says like, go for n elements. It's very, like, the iterators are a very strong concept that is not often used in competitive programming, I believe. Because all std collections can be constructed from each other using iterators. So it's one particular reason to use them. If you want to convert a vector to set, right? I don't know. Like, if I wanted to convert just entire vectors, then I would use this, right? But I can also take a slice if I use this. So pretty useful, I think. Also, if you've seen the implementation of some sorting algorithms in the standard library, it also takes like first iterator and last iterator. Because a pair of iterators is a very cheap way to represent a subarray or subset or whatever it is. Yeah. And if you can use next without any parameters, it will just be equivalent to next one. We have problem D, unfortunately. So problem D, Hamiltonian cycle. We're given a prime number P and positive integers A and B. Want to determine whether there is a sequence of P integers from A1 to AP, which is a prime number. Okay. Satisfying all the conditions below, and well, again, a constructive problem, but maybe it's different actually. Like, this suggests that graphs are involved. I'm not sure how. Let's see. So all of these numbers are from 1 to P minus 1. Okay. And there are P of them. Okay. A1 equals AP equals 1 is a perm. Okay. For every index, at least one of the following holds. So the next value is either multiplied by A or divided by A, or multiplied by B or divided by B. Why would you want to do that? It's just like, oh, okay, I see. So like normally I would take it like we want a permutation of residues modulo P. Well, shifted by 1, it's irrelevant. No, just residues, okay. Which is a multiplicative in some way. So if A is a generator, then we are done. Or B is a generator, then we are done. Otherwise, all values that we can get from them are like A to some power K and B to some power, I don't know, A to power I and B to the power of J. STD advance changes an iterator in place, and STD next returns the new iterator. I believe this is all the difference between them. Okay, I and J may be negative, but basically, like, we can very quickly find what is the value of I such that A to the power of capital I is equal to 1 mod P. And then we can also find the corresponding value for B. And it means that we can have I will be, let me enlarge this a bit. I will be from 1 to capital I, and J will be from 1 to capital J. Or minus 1. No, to J including. So one obvious problem that may happen if this set does not contain all residues. This is a bad problem. Somebody saying that this one is hard. Maybe. It's like 700 points. So it is a problem that typically would not end up in ABC. So it's like harder than ABC problem F. But I believe that I solved some of 700 rated problems in the past. We can check. Competition history. Which one is AtCoder regular? I believe that Keyons is AtCoder regular. Oh, we also have this. How do I see the specific results? I have to click here. Yeah, like I solved such problems in the past, although that was a very special problem. Yeah, no, it may be quite hard actually, but we won't find out if we just give up. Okay, so we won't give up, obviously. No, well, yeah, but that was like 600 treated. Okay, back to our problems. We should not spend time looking at the past sendings. Okay. Should we just find capital I and capital J? I'm going to have something to start with. Let's make them long because I don't trust myself in modular operations, not overflowing. Okay. So. Let's say AI is equal to a to the power of I. So originally we start with, no, okay, we will have to do it like this. J equal B. So while AI is not equal to 1, we should say like AI gets AI times I modulo P. The same goes for Bj. No, there will be two different separate cycles. We also increment the value of I. So by the time we exit this loop, I will be equal to capital I, which is already of some use maybe. I don't know, I don't have a clear solution in mind, but these values look important at least. Maybe we need to study modular arithmetics a bit more from this one. What can be useful here? Primitive root, which I believe is generator, may be useful. Discrete logarithm, probably not. Yeah, but the problem is like if we could choose A and B, then we could choose generator, and there are efficient algorithms to find the generator or a primitive root, whatever you call it. It is like fairly efficient in practice. No, wait, what am I saying? For prime P, every number. No, clearly not. Like 1 is not a generator, so probably not every number is a generator. No. Yeah, definitely should have studied number theory better. Doesn't look particularly useful for our purposes. Well, at least we have these values of A and G. Probably, maybe not. We will also need the value that were the powers of these guys. But maybe not, I don't really know. Like it is just, I'm trying to get something that looks reasonable, given the problems that we have. Okay? So like, what's going on is that we have a to the power of 1, then a squared, and a cubed, etc. At some moment, a to the power of I is equal to 1 modulo p. And the same goes for b and g. And I am thinking that these values may be useful as well. But I don't really know how to combine them into one thing. Do you guys in chat have any idea? Chat. No, it doesn't look like. Well, yeah, this one is hard, so we should think a lot. Let's try to. I don't really know, maybe it is just, maybe we expect to start with, maybe like, I don't believe it, but what if we just start like multiplying by a while we can? And then let's say, here we can't do it because a cubed is 1, right? And we say like, okay, if we can't multiply by a, let's multiply by b, right? And so in general, we will have ai, bj, and then suppose that we can't multiply either of them, so there are two previous, yeah, I'm just trying to come up with random ideas, so let's say that this is, like we can't add 1 to I because it will match this value that was previously here. And we can't add 1 to j because it will match this value. Right, for some potentially different values of I and j. Both of these things, of course, happen modulo p. Somebody is asking about good resources for dynamic programming. I believe that people are using that site called SES, Finnish website. It has like a lot of problems, and yeah, a lot of people use it for trading recently. I don't. I believe it was developed after I started CP, so I just used Codeforces a lot. Just solved some random problems from past competitions and it worked for me. But you can give that SES thing a try if you want to. Okay, so let's get back to our business. If this happens, what does it mean for us? It means that if we divide, then we get 1, right? So this is equal to 1 modulo p. And not only this, but also this. G2 minus G minus 1. Do we see any contradiction here? Like why this can't happen? Because if this can't happen, apart from some obvious test cases when we ran out of all possible powers of I and J, then this sounds like a constructive solution. But maybe this can't happen. And then we are stuck. Okay, I don't like this part, so maybe I just need to multiply by A. And here I don't like this part, so maybe I just have to multiply by B. Oh, maybe we should just take a closer look at what happens. Yeah, I start to remember some very useful number theory, finally. Let's take, I don't know, b equals 7. Or maybe 7 is not the best choice, but we'll see, A equals 2, I don't know, B equals 3. The idea is that if you start from 1, multiply by 2, get to 2, multiply by 2, get to 4, multiply by 2, you get back to 1 because you got to 8, which is equal to 1. Modulo 7. This is equality modulo 7. And you can also start from 3, then you will get to 6, then you will get to 5, and then you will get back to 3. This is like edges that A provides, and we also have edges that B provides. In B is like we go from 1 to 3. From 3, I don't know where we go back to. Probably to 2, then to 6. Okay, B equals 3 is not interesting because we can just loop over everything. So let's cut it out. And let's say that we have, I don't know. Oh, there must be not much of a difference here. What do we choose? Yeah, I believe that like 3 is a generator. Is 5 a generator? I don't know, let's try 5. From 1 we go to 5, I believe it means that 25 modulo 7 is what, 4? Yeah, we will just walk this way, road in the reverse order. But the general idea is that like when you multiply by A, you get, if you don't generate the entire set of residues modulo P, and you generate some like cyclic subset, and you have several disjoint sinks of length capital I in both cases, or maybe in multiple cases. So as we know, capital I divides P minus 1, because if you're familiar with group theories, and this is like I believe you have to write it with a star, and then it becomes a group, So every such thing is a subgroup generated by some element. Oh, I didn't realize I'm covering this thing up. Yeah, let me fix this a bit because I did not realize that. Maybe like this, I don't know. Lock it and performance modes. Yeah, I was writing some formulas here and didn't realize that my image actually covers them up. I'm very sorry for that. You know, first stream, it was expected to have some technical difficulties. So back to our problem. Like each element, both A and B, separate all residues into some subgroups, all of which are of size capital I. And then the question becomes like what transitions between these subgroups the value of B provides, right? Because I believe that if it provides like reasonable transitions, then we can just do what I wanted to do, which is start here, loop as long as we can. Then we find out that we can't loop any longer, and we say like, okay, where does B takes us? And it takes us here. We'll loop again as long as we can, and B takes us here, I believe, and we do our thing again, and then we miraculously get back. It is not always possible. I believe that, like, for example, B can be equal to multiplicative inverse of A modulo P. And in this case, our, like, this green lines, they will be just opposite direction. And obviously our graph becomes disconnected and there is nothing we can do, right? So I believe that if they are mixed, then they are let's say. If they are mixed in such a way that we can visit each of them, then we can just employ our tactics here. Like just multiply by A as long as we can. If we can't, multiply by B. Maybe it won't work, but let's see. No, like probably we should just examine the structure of this graph better, because it consists of two groups of cycles. And either it is disconnected, I believe, or there is a way to construct Hamiltonian paths easily. I'm not sure what it is, but it sounds something like this. Maybe our greedy way works, so like multiply by A as long as you can. If you can't, then you can't. Maybe it doesn't work, and we'll have to think more. I assume that it doesn't work because it sounds like a very logical thing to do, and it will be disappointing if it works. C0 equals 1, and we also want not vector but set of scene integers. I believe we can initialize it like this, or maybe we can't, and the compiler will tell us. So first we try to multiply it by A. Second, we try to multiply it by B. Like if not seen count multiplied by AC, then we can say like CI gets AC. Else we can check this. If not seen count BC, CI will just get BC. Else I think we will have to output -1 or something. Oh, we just output no. Okay. And I don't know, return 0. I assume it doesn't work, but because otherwise it is a disappointing problem. But let's check it. Maybe it will just fail the samples and save us from the necessity of trying it on the actual cases. Like actually submitting it. Okay, we generated some permutation. That is not good. Oh, of course. I did not insert it in scene. What I was thinking. Okay, disappointing start. Our strategy never works. Or probably because last time around we get 1. So we should actually do it like this, and we say like C p minus 1 gets 1. Yeah, because we were like, we saying no, we can't repeat values, but actually we can repeat the first value, right? Looks a bit better this time around. So at least it passes the samples, and I believe with the exact permutation printed here, but not with the exact permutation printed here. Interesting. I'm pretty sure that it's wrong, but like you don't get 10 minutes if you don't solve the problem. If you know what I mean. You don't get the pen. Yeah, okay, immediately. Okay. Just how bad is it? Random, yes. Okay, so if the answer is no, then we always respond no, because we can't find. If there is no answer, then we clearly can't find it. Also, but our algorithm clearly fails a lot of so it does not find well, wait. How did we fail the first sample? Did I wait. What? Or probably because the last time around we don't get back, or what? Ah, that's tricky. It is very tricky. Like you see, we got 6-1 here. And you can't, I believe, neither multiply nor divide by 6, like by 4 or 5 to get 1 from 6. Fascinating stuff. So like we walked all remainders, but we did not get back. Whoa. That is very interesting. Maybe there is a constructive algorithm, but like smarter than this. We can actually generate the cycles, right? The cycles are not the problem. The problem is how do you connect them? That is the problem. I don't know, let me see what you guys think about it. Oops. Okay, this cycles condition is complicated, right? One of my friends, not watching on YouTube, but just watching, like, not in the chat, but just told me that we actually want to have a different representation of that cycle structure. Like, these cycles are terrible to work with, and I do agree, but I don't understand what are our other options. Like, we have a to the power 0, b to the power 0. Okay, we have it. We have a to the power of 1, b to the power of 0, which is a to the power of 0, b to the power of 1, which is b. I assume we can represent it like a grid, but I don't see how it helps us. Oof, AtCoder contests are quite hard, I must say. No, I will just stop writing this thing. I should take just the larger brush. Okay, so we can align all these numbers that are reachable in a grid, but what do we do with it next? What do we do with it next? And then it goes in both directions. I should just use this rectangular tool. We have such a grid, but I saw that elements may repeat here if we take that B and J that we found earlier, no? Or maybe you want to stop at some place. It should not, okay. Yeah, now I think I know where we are going from here. Like we will generate this table column by column, and at some moment we will just have to stop. Yeah, and then the entire grid is similar to what we have here, I believe, or not? No, that's just so complicated. Okay, like a proper grid should end with A0 bi minus 1 or j minus 1, I should say. And here we will have a I minus 1 bj minus 1. Here we have a to the power of I minus 1 and then b to the power of 0. Right? But this grid may contain like repetitions, I believe, which is not exactly good for us. And in this grid we can move like as in a normal grid. And of course, finding a Hamiltonian path in a rectangular grid is much simpler, but if this grid has repetitions, then I don't understand how I should work with it. Like if there is a like if this is a grid without repetitions, okay, like this grid contains all possible residues modulo p. although there must be an even number of them. But then finding a Hamiltonian, okay, let's say like 3 times 4, 12, pretty reasonable if our modulo, if our P is 13. Yeah, then finding a Hamiltonian path is pretty easy, path, right? You just go like this. And this is whatever even dimension you have. But then how to find this subrectangle which will have no repetitions, I don't understand. Like, because there are multiple ways that you can try to select it. It may be like this. It may be like this. Or it may be like this. And maybe one of them works, but others don't. For some reason. Or does it matter actually? Does it matter? If we have one even side lens? No, I believe it doesn't matter, because we can, like, as soon as we get that grid without repetitions, we can take any of them. Now it becomes a question of how do we find it without repetitions. Okay, but this is clearly not what we wanted. And what we wanted was to stick to the original plan of computing I and j. No, I don't work at neither Google nor Facebook, and I don't actually, at the moment, I don't feel it I should work there. Like for me, it means moving to a different country, and I'm not exactly ready for this. I don't know. Like there are challenging tasks in pretty much every company if you want something like that. Yeah, the problem is that we can't generate the entire sync because it can be very large. And without generating, I don't know if we can take any subrectangle. Let's try. So C0, let's say it gets 1. Okay. Like we start with this corner. No. You didn't see anything. Then we will go this way until we reach AI equal to 1 modulo P. Then we will build the second column, etc. So we should do the following. No, not exactly like this, but rather like what? We'll have 2 loops like this. C0 back is not equal to -1. No, I believe that I should create a counter I. Okay. No, it's J. You are right. Not equal to 1. And here I say like CJ push back. I take CJ back, multiply it by A, take it modulo P, and append it to CJ. And I believe I appended one extra, so I will not actually if it is not equal to CJ 0. Because here it won't be 1, it will be not equal, well, here it will be equal to B. Here it will be equal to B squared. So I really have to compare with the first value in every column. Bro, that's quite complicated, I must say. Logic here. And the second, like this generates one row, I believe, one column, and this will generate one row. So generating rows is not hard. We just say do this, and then I say like C and place back. Like I want to create a new column. I want to create a new column, and then I want to start it with CJ 0 times B. This is what I want. I take modulo P, of course. CJ 0. No, just J plus plus. Like I want to move J here. But I also want a condition here. Which will do I don't know what, but probably it will say like y C0 size times C size. So the number of entries in the entire table is smaller or p minus 1. Like when it gets to p minus 1, we hopefully got all the remainders, and the one like we will have to get rid of one extra column, but that's all right. We say like C pop back. Oh no. Okay, let's just say that we have like counter of total number of elements. If it, oh, okay, here it got equal, so I actually want to remove last element, decrement I. I is not actually our I for A. I is the number of entries in the entire table. Here plus I. I believe that we will create one extra entry here. We created one extra, so while it is not equal to P, when we created one extra, it will get equal to P. So we will have to say C gets pop backed and I gets decremented, and from here we want to loop over C. we want to find that Hamiltonian path. It goes something like this, or probably if the rectangle is something like this, then it should go like this. Oof, 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 oof. And we should also like keep track of all the numbers that we have here. The idea is that we will use that set to check if it is possible, like if our table did not end before we could get all remainders. I believe that you want something like this. So this is initializer list of one element, and it will get converted to a vector when I say emplace. So if it's not equal, we can just print no straight away, else we have to walk through this table with a Hamiltonian path. Oh, it is very not nice. Like we have a lot of cases here, I believe. No, actually, do we have a lot of cases? N is this. Now we have table n by m, and we want to traverse it, like to go once through every cell. Normally, I do it this way, if n is even. If n is equal to 2, then okay. No matter what happens, we want to say that answer is yes in this case. And I say like, okay, print 1. I want to say print the value of the table at probably 1i. Then I want to go in reverse. Man, there is no chance that it gets accepted straight away. And then I want to output this, I believe. This is for the case when this is 2. So I go like here, here, here. Else if this is like this, or remember all these kinds of problems when you have a matrix and you want to traverse it, and that's just this. This is just so not nice. I don't really know what to say. It is just not nice. Perfect explanation. But really, like, you don't want to figure out indices for this traversal once you've realized that the main thing is table, the grid in the solution. I believe that in even rows we go this way, and then in odd rows we go this way. We start from first element. So this is an even row, this is an odd row. Here we should go in reverse. List one. So this is like all but first column, and then we say like for int j gets m minus. No, actually for we should print the first column in the reverse order, which is done like this. Trying to figure out the indices here, and wait, this was actually I then at least one of them should be like here. M modulo 2 is equal to 0, I believe. And I think we just want to swap this. Probably swap this, and most probably swap this. Yeah, we just like transpose the matrix, I guess. Must be terribly wrong. I just realized how long it will take to debug this. Oh my. Oh my, oh my. Why did I do that? Like, if it was pre-recorded, I could just cut it here and come back like 30 minutes later and say like, okay, I figured it out. Does not take one argument, which is where? I don't know, probably you just want to say it like this. Oh, yes, perfect. What do you think? Why it actually breaks? Wait, can I say like in place back nothing and then see back, push back this value? Does it make sense? I hope it does. No. Okay. Let's just check that we at least generate everything correctly. And let's say we don't do anything else. Like this is all we wanted to generate the table. Will it work then? Oh, okay, so it breaks even before we generate the table, or during the generation of this table. I guess you... Oh, okay. I don't really know, there must be a very simple way to do this, but I don't know. Let's just leave it as it is. I don't know all the tricks about... Yeah, let me just clear this mess up. Okay, we generated the table now, at least we got it working. Will this work as expected? I don't know. Probably not. Well, it generated some permutation. Here it generated some permutation as well. Here it said no. Here it said no. Okay. Our virtual participation is over long ago, but maybe we will at least solve it now. Why it was runtime error? Because I created a vector C of size 0 and I tried to push back to its 0th element. And now we apparently get some... Oh, I commented, yes, I commented necessary lines. I'm sorry. Yeah, like I created this vector C without any elements and then I accessed C0. Which was obviously wrong of mine. Congratulations to ourselves. I believe this is where we will unfortunately end this stream because I got to go and well, we solved this problem. So just a recap, the idea is that all values representable as product of some number of A's and B's. You can think about the largest power of A before it cycles back. You only have a finite number of choices in the set of residues, right? Modulo P. This is like set of values from 1 to p minus 1. There are only finitely many. So if you consider a to the power of 1, a to the power of 2, etc., it will cycle back for some value of I. It is equal to 1 modulo p. So you could think of it like we start with a to the power of 0, which is also 1. So it doesn't make sense to take this again. Then you can say that the same thing holds for b and some power j, and you get like this. Then you can put all these values into the table, which potentially contains duplicates, but I don't really want to think about these duplicates. I say like, okay, we will take for several first columns as long as don't get the necessary size. And necessary size we expect like we expect by p minus 1 residues. So this is n, this is m. We look as we generate new columns as long as n times m is smaller than p minus 1. This is what we did here. Well, that's actually smaller than p because the way I wrote do while and not while loop. So we generated several first columns, and then you want to find a Hamiltonian path in a grid, which is easy. You like if it has only 2 columns, then you go like this. If it has more columns, then you go in this zigzag, not zigzag, but I don't know. If you played Snake back on the back in the 2000s, on the mobile, then you know, like, and I assume you know how to get a long snake. This is the idea. Yeah, so and then we just had like several possible options which direction it should go, because if we only can, like, let's call this is a horizontal snake because it mostly travels horizontally. We only can have it if number of rows n is divisible by 2. So if it's not, then like, I don't know, let's take a different rectangle. It was like 4 by 3, let's take 3 by 4. Then you can do the same thing, you just have to go to have a vertical snake. And I basically transpose the indices here and like switch every indices and also every n for m and every m for n, and it worked. Unfortunately, we don't have time to solve E, but maybe I will upsolve later and publish my solution on GitHub. Although I don't know why you would like to see my solution. I believe since some time AtCoder has like official editorials, probably with code. I don't know, I don't really use them. But yeah. So why don't transpose it? You mean like explicitly in code? Because I don't know. I just transposed the indices. I thought it is the fastest way to write code. Maybe you are right, and it's simpler to transpose the array. Like, you know, like, because we are writing in C++, it's not very comfortable to transpose an array. I know that in Python you can have something like list zip matrix, list zip star matrix, and this basically transposes matrix. And this is like really cool. But in C++, I don't know such as syntactic sugar construction that provides the same result. So I just decided to transpose the indices. Yeah, maybe it's stupid of mine. If you know, if you like have a library function that transposes a matrix, maybe like you should use it and don't listen to me. Yeah, I just provide some solutions. I don't say that it's the best from the readability point of view. Okay, I agree that it is terrible. We should have created 3 functions, everyone taking care of its particular case, like this, like solve n equals 0, solve even n, solve even m, or probably solve odd n, and then just call them, because this is definitely a mess. And also generate table should be a separate function, but again, like I believe that yeah, I took a quick look at book that says things that we mentioned earlier book, and like the introduction contains one very nice line. They do not need to be maintained after the contest. So like, it's okay to have terrible code at the contest, because you won't see it again probably, like unless you are very smart and remember all the problems that you ever seen, and then you just come back and reuse your code. And that actually happened to me several times, like in lead code contest it definitely can happen, but not that much in code forces, I don't know. Last lead code contest I just reused largest rectangle in histogram and I added prefix sums to it, so probably it saved me some time, because I always forget how to write that stack sync for largest rectangle in histogram. So yeah, but most probably you won't see this code again, so it's fine if we just write it terribly. As long as you are sure what your indices mean, it's fine to have one variable, one letter variable names, etc. Yeah, I think I will put some links down in the description. I actually haven't read it like completely, I just read the introduction. I took a look at like content section. I believe like it contains something that I don't know, but not much. Like for example, Burnside lemma, I believe I knew it in school already because I participated in mass Olympiads, but probably most people don't know it and don't suffer from it. Yeah, that's tough reality. I must surely need to read some sections like graphs and matrices. No, I actually knew about that thing. Oh, that's it. No, okay, I did not know this, and I don't think that I will need this, but if you're preparing for like, I don't know, ICPC World Finals, that probably you need Kirchhoff's theorem. Yeah guys, so thanks everyone for watching. I really have to go, so sorry for not being able to solve problem E on stream. Maybe next time, but I don't actually know when. I will have to rewatch the entire stream, or at least some parts of it, to get the sense of how fast I am going, how slow I am going in several parts, to adjust to like, produce better content, you know. So yeah, this will be it for today, and I will see you, I don't know, next time, maybe even tomorrow, with Upsolving of Codeforces round that I missed. Something like this. Yeah, bye bye. Actually, what? Oh, yeah.